Friends, today we will see our last chapter, that is polarization. See, in beginning we have started from geometrical optics and optical instruments, in which cardinal points of a lens system, then eyepieces, that are Huygens eyepiece and Ramsden's eyepiece. Then we have already discussed about the interference in second chapter, how the interference phenomenon takes place, and interference pattern we can observe by the Newton's rings experiment. And that Newton's ring experiment we can use for calculating the wavelength of monochromatic source. After Newton's ring experiment, again for interference pattern we have discussed the Michelson's interferometer, then in which in the application part we have learnt determination of wavelength, and difference in wavelength can be calculated by the use of Michelson's interferometer. Then we have discussed the third chapter, that was diffraction. What is the diffraction phenomenon and diffraction at a thin wire. Then the optical, we can say, instruments in which resolving power we have already discussed. Resolving power of optical instruments, that is a resolving power for prism and resolving power of grating. After completion up to 3 chapters, now we are entering in polarization. Then this is nothing but the optical phenomenon when the light is coming from common light sources. Then that light is unpolarized. The state of polarization cannot be detected by unaided human eye. Then an understanding of polarization is essential for understanding the propagation of EM, that is electromagnetic waves, guided through waveguides and optical fibers. See friends, that polarized light has many important applications in various industries and in engineering field. One of the most important application is in LCDs, that is in liquid crystal displays. This polarization concept widely used. Again, this polarization concept is also used in wrist watches, calculators, TV screens, etc. See friends, in this polarization, the important is Moore's law, in which we can have see just the things which we have been already discussed here in concern with the polarization, that is nothing but the light which is coming from common light sources, that is unpolarized. The state of polarization by unaided human eye. All these things we have discussed, and this polarized light having a many important applications in an industry, and one of the most important application in LCDs and TV screen, in wristwatches, calculators, etc. Then the 18 loose molds. This is a Moore's law. He has been developed such a law for getting the concept of polarization. He says that when a perfect polarized or a polarizer, see in the chapter we having two concepts, that is a polarizer and a analyzer. He says that when there is a perfect polarizer is placed in a polarized beam of light, see this is nothing but a polarizer. From this common source, or we can say unpolarized incident wave is incident on the polarizer, and here we get polarized light, and that having an intensity I. See, this having an intensity I of the light passes through it and is given by in this way. Here I equals to I1 cos square theta, and it is nothing but again when we get I0 by 2 cos square theta. See, these formulas having their own meanings. Here I0 is nothing but the initial intensity, and theta suffix I is the angle between the light's initial polarization direction and the axis of the polarizer. Friends, in examination for uh, multiple choice questions, they can ask the Moore's law states that, and at that time we have to keep in mind this relation, that is I equal to I0 cos square theta I, and I0 is the initial intensity, theta suffix I is the angle between the light initial polarization direction and the axis of the polarizer. Friends, afterwards we have to see the next concept is concerned with the polarization, that is nothing but the double refraction, because on this concept the Huygens theory of a double refraction in inaxial crystal is depending, and therefore see here the double refraction is nothing but the phenomenon of causing two refracted rays by a crystal. Keep in mind this definition. The phenomenon of causing two refracted rays by a crystal is called double refraction, and therefore when unpolarized light passes through a calcite crystal, then we get O ray and E ray. O ray means ordinary ray and E ray means extraordinary ray. Therefore, simply keep in mind the phenomenon of causing two refracted rays by a crystal is called double refraction. See friends, for this phenomenon we will see about Nicol prism, how we get the linearly polarized light through nickel prism. Before that, we have to see Huygens theory of a double refraction. Very simply, Huygens has been explained. The propagation of light may be treated in terms of wave surfaces. What happens if the wavefront stimulates atoms, which then acts as a source of spherical wavelets, all of which are in phase. They expand in all directions with the same velocity. Friends, in Huygens' explanation, in the concern with double refraction, he says that if we are having a double refracting crystal, then there is a formation of two wave surfaces simultaneously. Then the wave surface corresponding to O ray means ordinary ray propagates with the same velocity in all directions and is therefore spherical. Then again in next he says the wave surface corresponding to E ray means extraordinary ray is an ellipsoid of revolution about the optic axis. Since E ray travels with different velocities in different directions within the crystal. Therefore, we can say that the two wave surfaces touch each other at 2 points and the line joining these points defines the direction of the optic axis. See once again. Here we are discussing about the E ray, means when ordinary ray is passing through a crystal like a calcite or a nickel, then we get two type of rays, O ray ordinary ray and E ray extraordinary ray. Again here we are discussing about the another term, that is the optic axis. As light propagates through the crystal, the two wave surfaces travels in different directions in the crystal and ultimately two refracted rays emerge out from the crystal. See, the spherical wavefront of ordinary ray may be enclosed by the ellipsoidal wavefront of E-ray in one type of crystals, and such crystals are known as negative crystals. Listen once again. They may ask in multiple choice questions, what are the negative crystals? See once again, the spherical wavefront of O-ray may be enclosed by the ellipsoidal wavefront of E-ray in one type of crystal, and that crystals are known as negative crystals because the refractive index of the negative crystal corresponds to the E ray is less than that of O ray. See once again, they are called negative crystals because the refractive index corresponding to the E ray is less than that corresponding to O ray. See, the calcite crystal is an example of negative type crystals. Friends, in other case, the extraordinary wavefront lies within the ordinary wavefront, and such crystals are called positive crystals. See once again, they are positive because the refractive index for the extraordinary ray is greater than that of ordinary ray. In this way, we have to discuss or we have to study the polarization. In this chapter, the important terms, the important explanation we are discussing. Means what is polarization, what is Maule's law, what is the concept of double refraction, how we are getting O ray and E ray, then Huygens theory of double refraction, then what is the concept of optic axis, and then in next lecture we will see about the Nicol prism. Friends, this Nicol prism is also one of the important optical device we can see, by which we get the means that this Nicol prism was designed by William Nicol in 1820, and this Nicol prism also used in various polarimeter, in particularly Lorentz half set polarimeter, and after it we have to discuss about the specific rotation by using the half set polarimeter. Today here we will uh, stop this lecture, and we will meet in next time for next article. Thank you very much.